Good afternoon, everyone.
Good afternoon, sir.
Good afternoon, sir.
How are you guys doing?
Good afternoon, sir.
Good afternoon. How are you doing? You guys okay?
Yes, sir.
All right. So I'm giving you those three questions as warm up to the start of the class. I'm going to ask if you'll start with these. I'm going to ask that you work in earnest. I've given you one of each type of what it is that we've done so far. So I'll give you 10 minutes to start working on those. Please and thanks.
Sir, can you zoom it up so I can see the number? Thank you.
All right, I think that is more than enough time. Have you completed the assigned task? Is anyone still working?
Hold on, sir.
Is it just Logan alone working or anybody else working?
I just reach home, sir, so I'm just not happy with
I'm still working also.
All right, quick
just
and fast. I'll give you a few more, but
Yes,
quick
sir,
and
sir.
fast, please. Yeah, man. I'll give you a few more, but quick and fast, please. I really want, this is just to sum up this area. I'm moving into a new area now. I mean, shortly after this. So I want to make sure that you guys, would have gotten it. 5 more minutes. I'm seeing people coming in and leaving. I'm not sure what is happening. All right, so I must begin. I must begin. So we are finishing off Unit 1. Hold on there. And we'll start Unit 2 momentarily. So let's go. The question asks to evaluate the limit as x tends to 3 of 4x squared minus 11x minus 3 over x minus 3. What did you get for your answer?
13.
13, sir.
Anybody else?
And it's also a denominator.
Oh, it is Logan, it is also a what?
In denominator.
No, you need to learn the terms. It is a what, Logan? Nobody don't tell her. It is a what, Logan?
In the terminator. Yeah.
Oh, indeterminate.
Indeterminate.
Indeterminate. So you have to know, you have to learn the jargon. So can anyone agree that it's indeterminate?
Yes, sir.
Yes, sir.
Yes, sir.
All right. For those of you who don't know what we're talking about, x tends to 3, we are guessing that the function is going to move to is equals to 3 at the point where x is going to 3. So we're going to say 4 times 3 squared minus 11 times 3 minus 3 all over 3 minus 3. Three times 3 is?
9,
3
sir.
times. And 4 nines? 4 nines?
36.
11 times 3 is? Negative 11 times 3 is?
33.
Negative.
Negative 33.
Negative 33.
33 minus 36 equals?
3.
Negative.
And 3 minus 3 equals?
0.
And then another 3 minus 3 is equals to 0. So it's indeterminate. 0 over 0 says that it's indeterminate. It doesn't mean that the question is finished. It doesn't mean that the question is finished. What it means that it is indeterminate. What does this mean? There's something in the function preventing the true limit of the function from coming out. Can anybody guess what is in the function preventing it from coming out? What is preventing the true limit of this function from coming? What function is preventing it from coming out, guys? I told you this.
Sir, factorization, or that's not the answer?
No, that's not the answer I'm looking for. Look at the given function. Tell me what is preventing the true limit of the function from coming out.
X minus 2, sir.
Yes, thanks. So just say something, man. So guys, the x minus 3 is preventing from. So how do you know that? Because I cannot have a 0 existing in the denominator. Whereas I am allowed to have a 0 existing in the numerator. I cannot have a 0 existing in the denominator. It does not make sense. It is illegal. It shouldn't happen. It cannot happen. It is just. I'm not going to tell you anything else. It's going to come out in the other question. So now, I must do something in order to check to see what can happen. What should I do?
Factorize, sir.
Factorize what return?
Factorize the numerator.
Okay. Thank you. How do I go about that? What do I say?
Right. So you multiply the coefficient of A with the coefficient of no. Multiply the coefficient of A with the constant term,
Mm-hmm.
which
So
is
therefore,
4 times minus 3.
4
And
times 3
then
is 12.
yes. So you find two terms that when you when you add them you get B, and when you multiply them you get
Negative 12.
hold on. Yes.
No, you're correct. You get negative 12. All right. I'm prime factorizing. 2 into 12 goes?
6.
26 goes?
3.
3.
Can I use 2 again?
Yeah.
No, say no.
Step back.
No.
Say
Yes,
no.
sir.
No, say no. Don't say yes again. Say no.
No.
Good. What number what number do I move on to next?
Oh, 3. Oh,
Good
sorry.
job. Good job. So I'm prime factorizing. I'm prime factorizing. When I use my prime factorization, my factors come up seamlessly. 3 into 3?
Left back.
1, sir.
1. Yeah. So now, Rayton says I need a negative 12. He says I need a negative 12. So when I multiply both factors, I should get negative 12. But when I add both factors, I'm supposed to get in negative 11. What two numbers are you thinking of?
Negative 1 and positive 12, sir.
Really?
Yes, sir.
Sir, 1 and negative 12. That him
1
said?
and negative 12. No, man, him said the other way around. Rayton.
Oh, yeah,
Oh,
him
1 and
wrong.
oh, I apologize, sir.
Yeah. It's supposed to be negative 12 and positive 1. Why negative 12, Rayton?
Because when you subtract negative 12 from one, the answer is negative 11.
Yeah, man, and it's negative 11 you want. Is everybody okay with that so far?
Sir, just
Yes,
one
sir.
question.
Yes, sir.
Negative 12.
Sir, can you scroll down a bit? Or scroll up, I should say.
Why?
Can we answer question 3?
Okay, I'm coming. Kyle and somebody else said that they was asking the same question. Remember, guys, you're not practicing. And that's why I created these classwork questions for you. You're not practicing. So, or you get the 12. Hey, somebody will ask a question or two. So it means that at least 2 students in the class are not practicing. Guys will have to practice. You see, when I'm moving to the unit 2, I don't want nobody to get up from them system. I will tell you when I want you fully focused. If you miss it, you then lose it. Don't get up now. I'm going to go through this one more time. I'm given a quadratic expression, 4x squared minus 11x minus 3 to factorize. I'm going to multiply the coefficient of x squared by the constant term. The coefficient of x squared is the number in front of x squared. The coefficient of x is the number in front of x. And the constant term is that which stands alone. Therefore, which term is the coefficient of x? What is the coefficient of x?
In this case, -11.
Thank you, sir. The coefficient of x is -11. Everybody see that?
Yes, sir.
Yes.
What is the coefficient of x squared?
4.
Good job. What is the constant term?
-3.
-3 there.
Very good, -3. The methodology is I'm multiplying the coefficient of x squared by the constant. I'm multiplying the coefficient of x squared by the constant. 4 times -3 equals -12. I am not going to be prime factorizing -12. I'm just going to be prime factorizing 12. Hold on a minute, please. So I am multiplying the coefficient of x squared by the constant term. Now, hear me out. Yes, I know that the constant term is -12, but at this stage, I am not interested in the negative sign. Where the negative sign comes into play is when I'm multiplying both factors, because that negative sign will have to be distributed in such a way that it gives us a fraction or factors. I can't just say -1 and +12, because -1 times +12 gives me -12. That could work. But +1 and -12 also gives me that -12. But I need to know, I need to determine now which of them is what it is that I'm going to be using. One of them can use because two of them won't work. One of them can use and the other one can use. When I add both fractures, then I will get the middle term. So +12 and -1. When I add 12 minus 1, I'm going to get +11. +11 is not what I want. So I'll have to flip the factors, the signs. When I flip the signs, then I get what it is that I want. Now, let me show you how this prime factorization business works. I'm going to manipulate these prime factors. 2 times 2 is 4. I could use 4 and 3, but 4 and 3, when I add 4 to 3, then give me 7. That's not going to work. 3 times 2 is 6. 6 times 2 is 12. Okay, but 6 plus 2 is 8. That's not going to work. But see here, I can also use this 12 and this 1. So I can manipulate these factors here, but also I can use this and this. Every number has its own factor. So what are the factors of 2? 1 and 2. What are the factors of 6? 1, 2, 3, and 6. What are the factors of 12? 1, 2, 3, 4, 6, 12. So every number is its own factor, and 1 is a factor of every number. Do you agree with that?
Yes, sir.
Yes, sir.
Yes,
Good.
sir.
So now, I'm going to, ouch. I'm going to substitute my factors. My factors are 1 and 12. So watch me. 4x squared plus 1x minus 12x minus 3. Talk to me. Does that look okay?
Yes, sir.
Yes, sir, it does.
Mhm. Let me highlight some stuff. You know, somehow I feel like some of you are distracted, but what is to do?
I did opposite though.
Say it again?
I did the opposite. I put the 12 with the 4. So I can even out and put the positive 1 with the 3. So you can get the x minus 3
Mhm.
and x 4x plus 1. Because you need to cancel the x minus 3.
Okay. What is 1 plus 2, Rogan?
Repeat.
What is 1 plus 2?
2. 1 plus 2, 3.
What is 2 plus 1?
3.
Did it make a difference which number I call first?
No.
Okay, very good. I'm happy, your question is important, Don't think that I'm saying that your question is not important, Your question is important, and I counteracted your question with another question. Because I want you at this stage to recognize that, oh, come on, Auntie. Hold on a minute, please, guys. All right. So now, look on, you understand my counter question to you, my love?
Yes, sir.
All right, good job. Is there, does anyone else have another question that I can quickly answer before I continue? Okay. All right. So now I'm going to group. Want to pay attention here, please. And particularly so because I have a negative sign. So I'm going to put 4x squared plus 1x in one bracket. My middle sign stay out every single time. My middle sign stays out every single time. Now, when this sign here is a negative sign, it says to me that the sign outside here will have to be flipped because I'm factoring out a negative sign. So the sign that goes right here is going to be a positive sign. And if we want to double check, -1, there's an imaginary one here, -1 times a positive 12x gives me -12x. Do you agree with that?
Yes, sir.
And -1 times a positive 3 gives me a -3. Do you agree with that?
Yes, sir.
And the other thing is that I want you to remember whatsoever sign that is here has to be the same sign that is here. I cannot factorize by grouping when those two signs are different. Does not make any sense. I cannot factorize by grouping when those two signs are different. They must be the same. So if when you catch there, so and you recognize that one term, one sign is positive and the other sign is negative, boom, you know something wrong. You know something is wrong. So here my question to you now. What is common here that is common there?
X, sir.
Good job, good job, good job, good job. X is common, so I'm going to take out my X. What is left?
Sir, if 4x plus 1.
Very nice. What is common? What is common here? That is common here.
Three, sir.
Very, very nice, very nice, very nice. What is left?
4x plus 1,
1.
sir.
Oh, x. 4x, yeah.
What is common here? That is common here.
4x plus 1.
What is left?
X minus 3.
Excellent. So now what I have is is me rewriting the question. The limit as x tends to 3. The limit as x tends to 3 of
Excuse
now
me.
4. Excuse me? Hello?
Have you noticed in the class
What are you saying, Krista?
bouncing off? I just get kicked out a moment ago. Can you hear me?
I can. Your internet is unstable. You're very choppy. I think I get what you're saying, though. You keep bouncing out of the class.
Yes.
All right. Oopsie daisy. Are you still with us, Chrissy?
I'm still here.
All right, good. Try not to move up and down here. I don't know. Gosh. All right, so I've just rewritten the question. And instead of putting at the 4x squared minus 11x plus minus 3, I'm now putting a factorized term there. Then now I'm able to see that which causes me to not get my answer. Boom. Boom. I've factored it out. So what I'm now left with is the limit as x and 3 of 4x plus 1. Now I can try it. Now I can try it. Because I would have just reduced my original question. Assuming x to be 3, 4 times 3 is
12.
12.
and for sorry, plus 1 is going to be equal to 12 plus 1 down,
Yes, sir.
which is equal to 13. So the limit here is equal to 13. Are you okay with that?
Yes, sir.
Are there any questions, guys?
Sir, to be honest, sir, my only problem is with the 12, sir.
Your only problem is it?
With the 12x and the 1x, sir.
Or your problem is to factorize?
Yeah.
And the corner, you can have a big problem. Because if you don't factorize well, you're going to be in problem. And the next topic that I'm moving into, unit 2, is going to highlight that problem. But
No,
the
sir,
corner, I thank you.
it's only with the odd number, no, sir.
Huh?
It's only with the odd number. You see, if it's with an even number, sir, well, all right. That is the odd number, my problem, sir. Like the 11x, the odd number is my problem, sir.
Okay.
You can zoom out, sir. I can get a screenshot of this, sir.
Sure.
On the
I'm
screen,
just patiently waiting for you to reach number 3. It
You're
has my head
patiently waiting,
scratching.
Christian.
I'm
You're
patiently
patient.
waiting for you to reach number 3 because I'm stuck.
Oh, okay. What is wrong? I thought you were saying you're patiently waiting for me to ask if there's any other question, but I'm going to say something here now. That's all right, Pops?
Yes, sir. I'm gonna get a screenshot.
Yeah, I'm gonna say something now, guys. And I'm gonna say it very slowly. Because I know without a shadow of a doubt in mind that there is at least one student other from the Carno who is not comfortable with this. However, I did ask the question, are we okay? And it's just the Carno.
Sir, are you hearing me?
I'm hearing you now. Yes, Rajiv,
I
go
was trying
ahead.
to unmute. Yeah, I was trying to unmute, sir. I think I missed a part here. The part where you take out the common, what is common in each of um the part where you find what was common with each of them, right? Where you have x and 4x plus 1, yeah, right in that line.
All right. So let's start from there, Rajiv.
Yes, sir.
All right. And after this, I'm not going to ask a question. If you're understanding, I'm expecting that you guys will say to me that you are following. All right, let's go. So I'm going to go the line before. The line up top here says 4x squared plus 1x in one bracket minus 12x plus 3 in another bracket. Here's my question, Rajiv. What is common between 4x squared and x? And then you reckon
That would be x.
that would be x. Good. So I'm factoring out the x, and then I'm going to ask what is left. What do you mean what is left, sir? When I take out the x from here, what is left? 4x. And when I factor out the x from 1x, what is left is just the 1. What is common between 12x and 3? You should recognize that 3 is a factor of 12. And in so doing,
Yes, sir.
I can factor out the 3. Very good. And what do I have left when I take 3 from 12x? Has to be 4x. And what do I have left from 3 when I take 3? 1. Go ahead, Nigel. Listen.
Yes, sir. That's right. If I know unmute. What if you had 4x cube?
Can't happen.
Not gonna happen. The maths don't work out.
You don't do a cubic equation, an expression like this. This way of doing the question is just for the quadratic. Cubic, don't have to worry about it, pops. We're getting there sooner than later. And be careful for what you ask for here.
No, I'm gonna ask you.
No. I'm just saying.
Possible
Yeah, I'm just saying.
A factorization.
Yeah, man, just be careful. Because sometimes we ask for much and we don't know how to deal with it when much comes.
Bite size, sir. Bite size.
Yeah, man. Bite size, that's right. All right, let's go. So continuing. So now that I factored out here, and I'm at the line that you asked me for now, Raji, I'm asking the question again. What is common here? That is common there. And you recognize 4x plus 1 is common. So when I take out 4x plus 1, see it here, so 4x plus 1. When I take out 4x plus 1 here, so what is left? The x here. So I write it down. When I take out 4x plus 1 right here, so what is left? A negative 3. So this is what is left. And then, if I want to double check, I can double check. Watch me. 4x times x is 4x squared. See it here, so 4x squared. 4x times negative 3 is negative 12. See it here, so negative 12. 1 times x is 1x. See it here, so 1x. And 1 times negative 3 is negative 3. See it here, so the same line, negative 3. So we know, so we answer right. And all I'm doing, I am not, because this is what I factorize, the 4x squared minus 11x minus 3. I'm substituting 4x squared minus 11x minus 3 for 4x plus 1 times x minus 3. And that is going to be divided by x minus 3. See it on here, so x minus 3. And the x minus 3 is cancelled. So I'm going to be left with 4x plus 1. I'm at 4x plus 1. I ask a question. Now that I've removed something by a simple operation, I'm going to go again to see. I can't get 0 over 0 again. You know? Sir, why can't you get 0 over 0 again? I'm asking you the question. Why can't I get 0 over 0 again?
Because you remove what was causing it to not reach the limit, which is the x minus 3.
Yeah, but don't come on, Raji. So yes, so that is correct, Raji. But let me ask you though. Do you think that when I remove it at this stage, I can get 0 over 0 again?
No, sir.
Why? Look at it, guys, and tell me why. So the answer is no, I can't get it. But there's a reason. Tell me why.
That's the denominator would no longer be.
Say it again?
Denominator would no longer be 0.
Right. I don't do I have a fraction in again?
No.
No, I don't
No,
have
sir.
a fraction. I just have a polynomial. So once I have a polynomial, I will never get 0 over 0. So the indeterminate, and that's one of the things that I wanted you to see. The indeterminate can only occur when I'm given a rational function. What is a rational function? Something in a numerator and denominator. So once I'm given a fraction question, that's the time we're going to talk about indeterminate. Check to see if it is indeterminate, sir. You have to check to see if it's indeterminate because you have something over something. If I don't have something over something, there is no way on earth we can have indeterminate 0 over 0 or infinity over infinity or negative infinity over negative infinity. Can't work. Can't work. Negative. So you have to be very mindful in that regard. You have to be very mindful in that regard. Let's go.
Yeah, you hear me, sir?
You already know?
Yeah, Mike's all right now.
Yeah, it's a comment. We are to be mindful of the signs, because that throw me off.
Yes, I've said this from day one, and I'm going to say it again. You see, in that first week, when I was taking my time with you, it's because I wanted you to see what is happening. I remember we used some negative signs from the left and from the right. You saw how patient I was. All of that, Halloween, was to build you to this stage. All right, let's
Yes,
go.
sir.
Yeah, man. Let's go. Let's go. Let's go. Número dos. Número dos. Uh-oh. Uh-oh. I don't know how to do this one. This one can work?
Number 2, sir.
Yeah.
Yeah, that right, sir.
Is that right?
Sir. Yeah.
Yes, sir.
Okay.
Yes, sir.
What I do? Substitute 1, 2, or 100 or 1,000? What I do?
Huh?
Sir,
Oh, sir, playing a trick on us.
Chris, leave me alone. I'm not paying no trick.
You're obvious, sir. We're going to find the highest number it's being brought to the highest power to. So that would be 3. So x over 3 is common in both the numerator and denominator. Can't
So
trick
what do
me,
I do?
sir.
So what do I do, Chrissy boy?
You're going to divide it by all the different factors. So it's going to be
Say terms.
the different terms. So
Okay,
it's going to
good.
be limit to x to the infinity bracket 12 to the 12, which is the whole number outside, and then x to the third power over x to the third power.
All right, good job. Thank you very much. Very nice. Very nice. You wouldn't understand the smile that is on my face, guys. It's a different feeling when you teach and students can remember. And not just Christian, I saw 3 persons unmuting, they're going to answer. Christian was just the fastest out of the block. But that's very good. Those of you who couldn't move out of the block at that time, you have to put in the work. But before I do that though, Christian, there is something that I must write. What it is. What it told me is perfect,
Infinity over infinity.
Okay,
because
thank you, please.
both tops and bottom, both numerator and denominator is tending to infinity.
Thank you, please, ma'am. So the next time I ask you the question, Mummy, start off right there, so or else you have to pay a fine.
All right.
Good. But that's very nice, though, guys. Everybody agrees with Chrisan?
Yes, sir.
Yes,
Good.
sir.
Yes, sir.
Yes.
sir, we're gonna lose man if we don't have that.
Me to tell you.
No, no, me really that ask a question.
Me know. That's why it's
Sir,
very
you can't
good
be
to
so,
talk.
you can't be so harsh, sir. Oh God, man.
Kenneth, Mr. Thaxter, don't write
Sir.
it on your see. Don't write it on your see. All right, let's go. So Christy is saying that we're going to find the limit as x tends to infinity. And I've identified now where she identified that x cubed is what it is that we're working with. So it's going to be 12x cubed over x cubed plus 5x squared over x cubed plus 6x over x cubed minus 1 all over 2x cubed over x cubed minus.
Sorry, miss out the one.
Which one?
The
Well, I don't
negative
think it can work.
over, yeah, man.
I put that there to see if you're paying attention. So I'm happy that you're paying attention.
Did you leave it to the cause a problem in the lesson run?
Oh, absolutely. Oh,
It
absolutely.
wouldn't go fact, you couldn't break it down any further, so it has to tend to 0. But if you leave it as 1, it's going to be fine.
Absolutely. I'm happy
You're
that
learning.
you're learning, and I'm very proud of you. Very nice. And I really want the rest of you to speak up as much. All right. So look at what is happening here now. Boom. This goes, that goes fully, that goes fully, that goes fully. Uh-oh. 2 of these go, leaving 1. All of that goes, leave 2. This goes and leaves 2. That stays. Agreed with that so far?
Yes, sir.
Yes, sir.
So I now have the limit as x tends to infinity of 12 plus 5 over x plus 6 over x squared minus 1 over x cubed all over 2 minus 7 over x squared plus 2 over x cubed as x tends to infinity. Kenneth, unmute, please.
Sir,
If you not write this too, you'll lose a mark.
no, I know that I did. I know,
Okay.
remember that one there.
All right, then cool. 1 over x cubed, 7 over x squared, and 2 over x cubed. So much of them have to write today? Tends to
Sir.
0. Yes, Papa.
Is it a problem if I leave off the negative of the 1 over x cubed?
The negative
Alright,
sign,
doesn't matter.
the negative sign right here, so?
Yes, sir.
Yeah, man. You
Remember
notice I
that.
don't have
Okay. Alright,
I don't
sir.
have it here because it doesn't matter really what the signs there is. I'm going to show you why. I'm going to show you why. That's not where it matters. Where it matters is here. So now I'm going to write the limit as x tends to infinity of 12 plus 0 plus 0 minus. See the minus coming here, not Kenneth? 0 over 2 minus 0 plus 0, which is equal to 12 over 2, which is equal to 6. All agreed?
Yes, sir.
Yes, sir.
Good job.
Yes, sir.
Sir.
Yes, sir.
I take your questions. Okay, there are none. Moving on. Tres. Tres. Number 3. Uh-oh, what's the first step again?
So yeah.
Yeah.
No, it's
Minus infinity over minus infinity.
infinity. Yeah.
All right, say that again. What is it?
Negative
Equal
infinity over negative
infinity over infinity.
All right, I give
Minus
you two.
infinity.
All right,
Negative
so-
infinity.
Okay.
So with this one, I got 5x squared.
I'm stuck because the the denominator is 0, and I thought the denominator hold power. So once I start tending to 0, I stopped.
Okay, but I don't reach this. May I ask a question? The limit as x tends to negative infinity. Yes, I agree. All of you so far are telling me that it is indeterminate. Tell me how so? What do I write? Is it 0 over 0? Is it infinity over infinity, or is it negative infinity over negative infinity?
Infinity over infinity.
Negative infinity over negative infinity.
Negative infinity over negative.
So when I put 0 as 0.
Who said it a while ago? Who said so a while ago? Eslap, are you?
Sir. Oh, sir.
Oh, are you Andrew? Take out
Yes,
the
sir.
lunch money. Take out the lunch money for next. You can put it on the table.
All right, sir.
Okay. Going one more time. Is it 0 over 0? Is it positive infinity over positive infinity? Or is it negative infinity over negative infinity?
Negative infinity over negative infinity.
All right. Why the more?
Because the x tends to negative infinity.
Okay, the
So okay.
All right, continue.
Oh, so if we're gonna put the negative infinity into the x, it would go straight down into negative infinity,
Really?
right? It wouldn't. Well, yeah. Yes,
No.
sir.
No.
No,
No.
it wouldn't.
No.
Sure.
Positive.
All right.
But no, the more I don't want you on you because we had a lovely exchange in class last week. And I said to myself, I think you are understanding what is happening. So when you come now and tell me this, Damar, it means that you didn't reinforce what you did last week. Last week you did exceptionally well in answering the questions. During the class, you got that aha moment and you started working beautifully. So the mere fact that you gave this answer suggests to me that you didn't do any work. Let me ask you, did you revise anything from last class, Damar?
Well, not this one, sir.
Okay. It shows though. Look at it, Damar. Okay, it's not dead, it's Damar. Look at it, Damar. Yes, I agree that it's going to negative infinity. But what is the indeterminate state? What do I write for the indeterminate state?
A
Sir.
the x squared.
Hmm?
So somebody else try help.
Yeah, man, but I don't know why they're not helping you. Help him out now.
Infinity over negative infinity. Only one negative
Yeah.
sign you have need.
Infinity over infinity, sir.
Why?
Because the exponents are positive.
Thank you very much. Nobody do remember that away from Rayton? Did I do that exercise with you to say that when I raise a negative number to an even power, the value is going to be positive? And when I raise a negative number to an odd power, the value is going to be negative? Nobody do remember that? That was the
sir.
last thing we did in class. Hello? Somebody?
Yes, sir, I remember.
Okay. The rest of you, do you know agree that it's going to be a positive infinity over positive infinity?
Yes, sir.
It was a curveball.
I'm on the fence.
Yeah, on the fence. All right. Again, pause a little because it's just the same set of people that are responding to me. And it don't go work. It's not going to work.
What's wrong, sir?
Sir, I didn't get to number three yet, but at first glance, I would have said negative infinity over negative infinity too. But
Yeah.
after what
Yes.
you just said, yes, that makes a lot more sense.
Yeah, man. And I appreciate your response, Reggie, but I wasn't really talking about you, because you engaged me in a conversation. I'm just looking at my participants list, and there are students in the class who just sit on my class and now open their mouth and say nothing. I mean, I run my class them Wednesday.
Call him, sir. Call him.
Well, guess what? To be honest with you, at this stage of the game, bachelor students, this is not associate degree now. This is bachelor's. When we used to spoon feed you guys for the associate degree, that is over with now. This is bachelor's. And you cannot sit in class on a Friday evening when I could be on the road, so could you, and just sit and just make the whole week tiredness just tumble down on you and you're just not saying anything. When you don't say something to me, you are going to move with your misconception. So it's when Andrew said something a while ago, I was happy when Andrew said it, because Andrew gave me a glimpse as to what he was thinking. I want you guys to speak to me so that I can correct your misconceptions, because when you sit down on it, you're going to believe that it is true, and it's all going to get the foolishness. But if you don't talk, I cannot get into your headspace. So I'm saying that one last time, and I'm watching my list, and I'm seeing those students who participate. Go ahead, listen.
So now that we understand says a positive infinity or a positive infinity, would it affect the answer where you get if you did calculate it?
No, I'm just saying to you that there are three types for this level of indeterminate. All right, there are three types of indeterminate. Coming to you, Kahim, there are three types: 0 over 0, positive infinity over positive infinity, and negative infinity over negative infinity. There are other types, because I could give a trigonometric ratio, but your syllabus don't talk about trigonometric ratios. So I could give a trigonometric ratio, and then no, it's going to look different. right? But for this level, we're going to do that. Go ahead, Kahim, and following, and then Kyle.
Sir, I'm not sure if I was in the class where you started this, but I don't understand why it's positive infinity over positive.
Okay, no problem. Kyle?
I was gonna ask to repeat why it was positive infinity or positive infinity.
Okay, no problem. Same question. Rita?
Sir, I wanted to know if you'd ever have a situation where you have a negative infinity over positive, or well, I know that it would be negative once you have a negative, but you specifically said negative infinity over negative infinity and positive over positive.
Right.
So would you have a case
So,
where you have
yeah. I think it is not you. Somebody has asked that question last class. Really, it's supposed to be positive, that infinity over infinity or negative infinity over negative infinity.
Okay, sir.
Right. Jamal, go ahead.
So, sir, you're saying that is because both of them positive make it be a positive infinity over positive infinity, and if they were negative, no, I don't understand.
Watch it.
Kind of.
Negative
No,
infinity.
sir was saying. Oh,
Go ahead. No, you can go ahead and explain. I have no problem. Go ahead.
Oh, sir was saying because it's raised to an even number, so it become positive infinity over
Oh,
positive
so
infinity. So if it was
it's
raised
like
to an
it,
odd number, it would have been negative infinity over negative infinity. Right, sir?
oh, get it
Yes,
now.
sir. Thank you very much.
Oh,
All right. So X to the so watch it. Watch this guy. Watch this, guys. Watch this, guys. So X to the fourth. So I'm putting in there. So I have 4 of them because the 4 up here tells me that it's 4 times. So negative infinity, negative infinity, negative infinity, and another negative. When I multiply these two, what do I get?
positive infinity,
And when I multiply these two, what I get?
positive infinity,
And when I multiply these two, what do I get?
positive infinity again.
Can you see that now, all of you?
Yes, sir.
Yes, sir.
Me get it now. Oh, this
All right.
that makes
Good job. And then now I have 2 of these, 2 of the x squared. So that means so when I multiply these two, I'm going to get positive infinity. So it's going to be positive infinity over positive infinity. You follow me?
yes, sir. So if the x was q, it would be negative infinity over negative infinity.
Very good. Yeah.
Okay.
Lower,
The first thing you have to do is identify what it's being brought to the power of.
Yes, ma'am. That's why I asked you. You remember the question that you gave me? That's why I asked you what was it set before, because you need to check to see what it is.
What it is before. Okay.
Yeah, man. Yeah, man. Because what I don't want you to do, what I don't want you to do is 1 second, please. All right. Now, shaping up nicely. So what I'm saying to you guys, and I'm going to say it again, you go to the supermarket, you buy chicken. When you buy the chicken, on your way home, you're going to decide, what am I going to do? Is it going to be curry? Is it going to be fricassee, boil, roast, jerk, you name it, stew, whatever it is. When you get the question, you have to look at the question to see what the question is saying. And when I look at the question, I'm saying, okay, how am I going to treat this? I know it's going to negative infinity, but the numerator is moving to positive infinity. The denominator is also moving to positive infinity. How do you know that, sir? Because the power in the numerator is even, so is the power in the denominator. So therefore, because of that, no, it simply means then that because the power is even, when I raise a negative number to an even power, my result is going to be positive. But sir, what if I put negative infinity over negative infinity? Would it be different? Would Would I still get the same answer? Absolutely. But I'm saying to you, help me out here, somebody. And it may not work. I don't know. But if you're doing computer repairs and you put a fuse in the wrong position, the system may work down, but it may not work optimally. True or false?
True, sir.
Yeah, man. And the same thing with that something here. So if you put the negative infinity over negative infinity, you're still going to get the correct answer, you know? But it's going to say to me that, yo, if this student's supposed to get 100%, you're now at a 99 because they never followed the thing properly. And you, in particular, calculus students, I am more precise with because of the nature of what it is that you're studying. You can't, in them failure and the foolishness. So let's go. But I'm happy though. This is us, I know. Oh, and incidentally, somebody was saying that they weren't here last class. Kyle, was it you? I'm not sure, but anyhow. Would you have recognized that your recordings are posted to the YouTube channel?
Yes, sir.
Yeah, man. Watch them. Watch them. Watch the recording, students. Send me an email or whatever it is, and Lecarno is your group contact person. Drop something in the chat. Lecarno can copy the something them and say, boy, sir, there is a common thread in the thing that them don't understand when you teach. And I tell you, talk to me. Tell me the things then. Just be respectful when you're telling me. And because I'm here to work with you. And if it means that you're not understanding how I'm teaching now or my writing, I'll have to go back to the drawing board and do something. And if you still not do it, I'm going to say, boy, you're the plan. Let me find somebody else who can do it. And then I'll substitute the class with somebody else because my aim is for you to make it. All right. So let's go now. So recognizing that it's indeterminate, go ahead, Justin.
So I'm not sure if I'm me alone, but when I watch the pause recordings, and when do see the working out in the videos.
You don't see the working out in the videos?
No, sir.
The
ones from 2020.
Or the ones from 2020?
2023.
Okay, well, I uploaded 2024 ones. So look at the 2024 ones.
Okay, sir.
Yeah, man. 2020, I never had all of them fandangles here that I'm using now. Because 2020, we did just win a COVID and we were fish out of water, so to speak. But watch it 2024. But it still can glance at those, because them still useful. That's why I don't delete them. All right, let's go. So we now know that we need to divide by the highest power. And it is gonna be 5x to the fourth over x to the fourth divided by x squared over x to the fourth. 5x to the fourth over x to the fourth. Oh, that cancels that. All of that cancels and the remainder of 2. So what I now have is the limit as x tends to negative infinity of 5 over 1 over x squared. As x tends to negative infinity, 1 over x squared tends to what? Tends to what?
0.
Tends to 0. Yeah, man. So therefore, what I'm left with is going to be the limit.
So is it okay to just say, instead of saying 1, I say x, that's fine?
No, it has to be 1 over x squared.
Has to be 1. All right.
Man. 2 different things. 5 over 0. Do me a flavor. Put in your calculator, so please. 5 divided by 0 and what you get.
0.
No.
Says math error.
It should. And if your calculator gives you 0 again, proceed, throw it out. Try it for me, please. It
Can't
should
divide by 0.
It can't be that. Right. Good. So this is going
Hence
to be
why I'm stuck.
Undefined, sir.
very good, Ashanti. It's undefined. There's no definition for something like that. There is absolutely no definition for something like that. There is no definition for something like this. Okay, so where's my working out? Are we okay?
Yes, sir, I'm good.
All right, do me a favor now. Go ahead, go ahead.
Yes, sir. Previous class, you said you were going to have a meeting about EducaSoft. Any information for us?
It is being finalized. That's all I can say. Just finalized. So I mean, I will get that to you in a jiffy, but it's being finalized.
Okay, sir.
Let me think back here. I mean, in a section.
Sure. Quick question.
Yeah, go
Sir,
ahead.
how you have negative infinity down there, sir, as x tends to negative infinity?
Because that's what the question says. X is going to negative infinity.
Yes, sir. Okay.
Go ahead, please, Riton.
Sir, so is it that the question is complete now, correct?
Correct.
Okay. All right. So is it that the only difference, the difference that I've seen so far is between a negative infinity and a positive infinity is what the result will be, whether it's a negative, no?
No, it's just an indeterminate form. Is it positive infinity over positive infinity or negative infinity over negative infinity?
Oh, so it determines the indeterminate form, but the working out will be the same.
Yes, I.
Okay.
But does the negative infinity affects the answer if it wasn't undefined?
No. Who just asked a question before you, Christian? Was that Rayton? Rayton, you just asked. Rayton, you just asked before Christian?
Yes, sir.
All right. Hear this. So your father is very rich, you see, and him give you piece of land. But it so happened that the land that him give you is beach front. When we say beach front, I talk about North Coast, beach front. What do you think can happen for you, Rayton?
Sir, I could get very rich as well.
You can what?
Wait. So beachfront. Is it that I'm supposed to sell that land and make some money, or I should develop it?
Boy, I mean, I think say you can develop it and make the money, Sell that. Sell that and you can buy all 3 of them Beverly Hills, Jacksonville, Oterios apartments. Why am I giving you that example? We spoke about positive infinity and negative infinity. Positive infinity is going in which direction?
It's going in the right, to the right.
And give me another synonym for right.
Increase.
No man, you're going up, down.
Okay.
And negative infinity is you're going where?
Down.
You're going down. So the point I'm making is when you have your negative infinity, it tells you that, and this is what happens in real life. When you have your beachfront property, when you go to these hotels, where do you find a car park for the hotels?
Well, sir, not on the beachfront.
No, clearly, but where you find the car park?
The garage?
In the garage. And where's the garage? Talk to me, no man. I know. Where's the garage?
Behind the beach?
Top floor?
Bottom floor, sir.
Bottom floor.
Bottom floor. Bottom floor. Yeah. And some of these apartments in Kingston that are being built now are being built with garages where? See?
Inside the building.
In the basement. You guys only just come to class and I learn and I try just learn something, you know. When you're not able to try to relate it to the real world. I mean, I tell you, say, I'm not so search and teach. When I teach maths, I have to connect it. There are some apartments on Ligoning Avenue right about now, almost across from Sovereign. All those apartments, because they're small lots, all those apartments they have their parking lot in the basement. There's one apartment that is built on stills because apparently they couldn't go down. So the first floor is a parking lot. Or the ground floor is a parking lot. And then the first floor is when the apartments them start. So the point is, you're going to go down beneath the surface of the earth in order to put on your garage. And some apartments say, you know what, here's the plan. We have water shortage. Or water storage tank is going to be beneath the buildings. So you have to take into consideration that negative stuff. So the question that I think you were asking, Rayton, is, but sir, there is no difference in the calculation. What is the difference with the negative infinity then, sir? Because if the question is done the same way, what's the point? The point is the direction in which you're going. Positive infinity means you start building from the ground floor up to the top floor, and then you put one next floor on top of the floor there, and the next floor on top of that floor. When negative infinity is going into the opposite direction, it means you're going to go down in the basement, and it depends on how far down in the basement you are going. Am I making any sense, Rayton? You can see that picture, Rayton?
Yes, sir, I can.
Yeah, man, yeah, man. So it is so I agree with you, Rayton, that the calculation is the same. And you may say to me, then, sir, what it is hullabaloo about negative infinity over negative infinity and positive infinity over positive infinity? It does make a difference. So if you are working with a contractor and you are the project manager person and doing the computer stuff, you have to indicate on it because that sign alone, that negative sign alone tells you, say, you're going in one different direction. And the positive sign tells you that you're going into another direction. So it's very important. All right? Go ahead.
So the end game is the same, sir, but it's just how you reach there.
Right. Because I can have a parking lot on the ground floor, but I can have a parking lot in the garage. So so the result is the same, but it's just the direction in which I'm going. Follow me?
Yes, sir. I'm catching.
All right. Good. All right, I'm moving on. So we're moving into our next area of study. I really hope that you guys are getting it. To be honest with you, I don't know how simpler to go. But I really hope you guys are getting it. We need to have a conversation now. By the way, do you guys need a break? A 5 minutes break?
Yes, sir.
All right, we're gonna take it. We're gonna take it. All right. Oops. E-G-I-N. All right. So I guess you're all back, are we?
Yes, sir.
All right,
I'm
good.
here.
Good job. Now, I want your undivided attention, please. Oh dear. I want your undivided attention. I am moving into Unit 2 that speaks about continuity and differentiability. Continuity and differentiability. So all that we were doing is just preparation for differentiation. So we're looking at continuity and differentiability. Now, a few of you, Lecarno, was saying, sir, you know, I understand this piece, but it is an odd number, even number situation. Kind of throw me off a little bit. All right. You have another opportunity to look at some stuff. Because I did say to you that our next topic will involve a bit of factorization. So let's go. Now, when does a function becomes continuous? I have some conditions here for continuity. If all three conditions don't hold true, it means say the function is not continuous. What is the opposite of continuous?
Discontinued.
Discontinuous. Very good, Ashantia. Discontinuous. So the opposite of continuous is discontinuous. So if it's not continuous, it is discontinuous. If it is not discontinuous, it is continuous. Now, what I want you to imagine for me, since I don't have you in front of me, just imagine putting your writing implement on your paper and you're making a shape, any shape.
Sir, go again,
Yes, sir.
sir. Never hear good. Put your what, sir?
I'm just saying, imagine that you have your writing implement, your pen or a pencil or crayon, on a piece of paper, and you're making whatever shape on that piece of paper. But at no point in time you're lifting that writing implement, but you're making the shape, and you're just writing continuously without lifting. That is going to be continuous. But if you're making a shape, and then you lift a pen or pencil or crayon or whatever it is, and then start again, now you have a point of discontinuity. You'll have a point of discontinuity. So continuous is when you just go along, go along, go along, go along, go along. Discontinuous is when you go along, go along, go along, stop, lift up, and go on again. Work with me. F of A exists. Sir, what is f of A? F is a function containing a variable. And when you substitute the value A in it, you get an answer out. So A is your input. So f of A exists. Watch it. It says the limit as x tends to A plus. Whoa. What is A plus? What will answer? When I read further, I say of f of x is equals to the limit as A tends to A minus of f of x. Sir, what is? Does anyone know what is A plus and A minus?
We try, sir. A plus. Let me say it's continuing as we said before, and A minus would reach a point of discontinuity.
Okay, all right. I love that attempt, but not what I'm looking for, but I love the attempt. Think about the last example, Alwyn, I gave before we went on a 5-minute break. What do you think A plus is? What do you think A minus is?
Does it have to do with the
A plus is positive, A minus
The
is negative.
direction it's going.
Very good. The direction. Yes, Alwyn, you're also correct, Alwyn. But I think I like this other example a little better. So, who said it again? Say it again.
Sir, the direction.
The direction. Alwyn, remember I said to think about the example I gave?
Yes, sir.
Right. So remember what I was really talking about was the direction. Positive infinity, you go up.
Negative infinity, you go down.
Yeah,
Yes,
go down. Right. So A, and then now who was it? Rayton, I'd ask Rayton the question. Come, Rayton, unmute for me, please. We're not
Yes,
going to
sir.
catch you something. All right. So when I started giving you the explanation as to what this positive infinity and negative infinity is, you started off by telling me an answer. Do you remember where you started off? You never went up. Where you went?
I went right.
Very good. So A positive is going to the?
Right.
And A negative is going to the?
Left, sir.
There you go. There you go.
Sir, so what about the A?
Don't worry about that, man. The A is fine. And I'm going to explain that. I just need to say something. I really do hope now that we are outside of week 1, that you recognize now that I cannot teach this course without giving you these real life examples. Can anybody say amen?
Amen.
Amen.
Yeah, man.
See in the dream, sir. We see in the dream.
Yeah, man. I have to, because I have to make the connections. I can't come here and come teach and just teach you straight, And I'm going to guarantee if I teach you 100 something, you may get 33% of it. But it's when I can connect it and I can see and I can use what it is that you say one give me. Because when I started off with the question with Rayton said to me, so you're going to the right? I said, no, man, the other one, the other direction. And then I recognized he was going, so I said, you're going up. So going to the right is correct, but going up is also correct, right? But hear me out. All right. Kakim asked a question. No, it's not Kakim, it's Kyle. Kyle, what was the question you just asked me? What is what?
What about the A?
All right. What do you think about the A, Kyle?
Sure, it will just stay in the middle.
Okay. All right.
Sir, isn't the A what tells you which direction it's going? Or the pole, not the pole, the sign.
All right. Start again, Kaki.
Can try, sir.
Go ahead, Nigel.
Would A be like a starting point, sir?
And
the positive determine the direction which part A go.
And
the negative determine the opposite direction where A would go or end up.
Okay. And we're doing this because you see this before?
No, sir, but based
No,
on
man, no.
example.
Nigel, think before you say no,
Yes.
Where have you seen this before?
I believe in the first class.
And what is the first class? Where you saw it, Kyle?
So with the number line.
Yeah,
Yes,
and what
sir.
topic were we looking at? What method were we looking at? When I'm not revising. And that's why I asked the question. When I'm not revise.
Is it the intuitive approach, sir?
The intuitive approach. The intuitive approach.
Yes, sir. Yes,
So,
sir. Intuitive approach.
So what may I say to you? So if the limit as extends to A to the right is equals to the limit as extends to A to the left, it must be equals to the limit as extends to A. Sir, what do you mean by that? For the intuitive approach, we said to you, say if the limit as extends to the right is equals to the limit as extends to the left, that the limit exists, don't it? Talk truth.
Yes, sir.
And then after that, no. And after that, no. And then the two of them are going to tend to the same something, don't it?
Yes, sir.
And then now, sir, move from the intuitive approach to the algebraic approach, where we just go ahead and just assume that x equal A, don't?
Yes, sir.
Did we get the same answer when we started doing the algebraic approach that would get for the intuitive approach? Yes or no?
No, sir.
Hey.
Yes, yes.
Yes, sir. Yes, sir.
Yes,
We
Yes.
sir.
did.
The
Yes,
algebraic
sir.
approach
Same
easier.
answer.
Same answer. All right. Press pause. Sure. Go ahead, Amoy, please.
Sir, I'm kind of lost.
You cannot?
Yeah.
Sorry. So what they said? It kind of lost?
Yes, sir.
Yeah, don't worry about it. Leave it alone. I soon come to you, Papa.
So, sir, wait, sir, you say the A
Hold on,
plus
the man. Hold on, the number, Papa. I say leave it alone. I say me soon come to you. Don't worry about it, man. You will find your way back home. I promise you. I'm just trying to bring something here, just to. You'll be fine. Trust me. You sure? All right, watch me. So we went to a question like this. And we're using the intuitive approach. See here, intuitive approach. And for the intuitive approach, we went to the left-hand side. We went to the right-hand side. But this left-hand side, I did not introduce everything to you right here. Why, sir? Because I was giving you baby formula. Now you start get dumpling. Watch me. What I could have said, instead of using left-hand side, I could have said to you, x tends to 1 superscript negative. Instead of saying right-hand side, I could have said to you, x tends to 1 superscript positive. Everybody understanding? Damoy, you understanding the negative? Go ahead, Damoy.
So, sir, when you put the positive, that means it would be that it will go to the right hand side. So
Very
it would
good,
be
son.
that you would specifically go to the 1.1 and so on.
Yes, son.
Oh, I get it now, sir.
Good job. All right. But I don't want to move too far now. So yes, so 1 is the right-hand side is going to be positive, because when you go to the right-hand side, think of the number line. Don't when you go to the right-hand side for the number line, a positive, you go to don't.
Yes, sir.
Yes, sir.
And then now we agree now, so the left-hand side going to be x tends to 1 superscript negative, don't?
Yes, sir.
All right, watch me now. Don't go too far now, don't blink. If we're using the calculation or the algebraic approach, what we're going to say right here, so? Talk to me now, man.
X equal 1.
You're going to assume that x is equal to 1, don't it?
Yes, sir.
Good.
Yes,
And what
sir.
is 1 plus 1?
2.
2.
But the limit approach 2, don't?
Yes, sir.
From the
Yes, sir.
right-hand side and from the left-hand side, don't?
Yes,
Yes,
sir.
Yes,
sir.
sir.
So therefore, this I say, what is this saying? This is saying the intuitive approach from the right-hand side, if it equals to from the intuitive approach to the left-hand side, it means that it then also it is also going to be equal if I just go ahead and substitute the value of a into the function. I'm supposed to get the same answer. Talk truth.
Yes,
Yes,
Sir,
sir.
go
sir.
again, please.
Yes,
All right.
sir.
What I'm saying to you, whoever just
Sir,
asked
so
the question,
basically,
go ahead.
sir, what you're saying is that, or part of what you're saying is that the direction of the limit doesn't affect the continuity of the function?
If them work out to be the same.
Oh.
Remember I said to you, if the right-hand side is equal to the left-hand side, the limit is of a good behavior and the limit exists.
Yes,
So what
sir.
I'm saying to you, if I'm given a function, the function f of a exists, it means I can substitute a value into the function. What it means, f of a, it means that the function has something that I can substitute some values in there so I can investigate what is happening. If I get a function that is only a whole number, the limit of the function is going to be that number. So if I gave you, find the limit as x tends to 3 of 100, what is the limit? What's the answer?
Repeat that, sir.
Sorry, can
if I say to you, the limit as x tends to 3 of 100, not 100x, just 100. What is the limit of that function?
It's 100, sir.
100. Because
Wait,
it's a
repeat.
constant.
So are you saying that the limit of x is turned into a fraction?
No. The limit as x tends to 3, 5, 10, 50, negative 1, 0 of 25. 25, so. What is the limit?
25.
25. Because the limit of a constant is a constant itself. You may not have no value of a or x for substitute in talk truth.
Yes, sir.
Yeah,
If
so the
you
limit of the
raise to a
constant,
power now, would that be a different thing?
it would be a different story. Right? So what I'm saying to you is, come, let us focus on this. What I'm saying to you is, this is not hard enough. I'm not spend more than 3 more minutes on this enough. Come, let's go. So what I'm saying to you is that why I have f of a, because I must have something where it is that I can substitute. I'm not talking about a constant, because you know that the limit of a constant is a constant itself. So when I'm saying to you f of a, it means that f of a exists. It means there's a function where we can substitute one value in it. Why, sir? Because I need to play around with that value to do some investigation. I need to play around with that value to do some investigation. Okay, sir, I think I catch it. Yeah. How do I play around with the value? I am going to look to see how the limit behaves as x tends to a plus. What is a plus, sir? It is going to the right-hand side. So we said 2.1, 2.01, 2.001, 2.0001. Yeah, them start of something there. And then when it says the limit as x tends to minus a, it means you go to the left. 1.9, 1.99, 1.999, 1.99999. Yeah. And then now, when we say, sure, we can't bother with the intuitive approach here, we just go fling the a in the function because we're going to assume that x equal a. Boom! We get the same answer. So it means that the limit as x tends to a plus, the limit as x tends to a minus, and the limit as x tends to a in and of itself gives you the same value. Then f of a must give you the same thing as the limit as x tends to a of f of x.
So, sir, it's like basically, I say, what you learn from the first class.
Absolutely.
Okay, understood.
So that's why I did. That's why I did what I
Sir,
did.
this is
Go ahead. Go ahead. What, Raji?
yeah, sir. I was just saying this is basically just reiterating the concept before.
Right. But so what I was doing in the first unit, the little baby steps is just to show you, give you an idea. Because if I came to class now, I said, okay, we're starting off from unit 2. The limit as x tends to a superscript plus. Sir, what is that? But now that I've gone through the intuitive approach with you, you should have an idea what a plus means and what a minus means, right? To the right and to the left. It's just not that we're going to graduate and not going to call it left-hand side and right-hand side anymore, because that's baby stuff. We're going to call it a superscript plus and a superscript minus. So a superscript plus is saying that you're going to the right-hand side. You should know this. And a superscript negative, you're going to the left-hand side. You should know this. And when I say to you that the limit as x tends to a, it means we just get fed up of the intuitive approach, and I'm going to allow and assume that x is equal to a and fling a into the function, and I will guarantee you, just like the example I just showed you a while ago, when we did the intuitive approach with that question, from the left-hand side, with the 1.9, 1.999, it tends to 2. From the right-hand side, 2.1, 2.01, so forth, it tends to 2. But also, when I substitute the value x equals 1 into the function x plus 1, and if 1 plus 1 equals 2, it means to the right, to the left, and at the exact point, it is equal to 1. That means the limit exists. F of a is equal to the limit as x tends to a of f of x. We don't write to say no. I've explained this three-pronged thing. These are the statement conditions for continuity. You must meet all three before the function can be deemed continuous. All right, moving on. Not spending any more time on that. I don't need to. Moving on. For example, it's asking me now to find the values of x for which that function is discontinuous or undefined. So another word for undefined is discontinuous. So you're learning something new again. Before, when we did a question with the 5/0, I said to you that it's undefined. And Ashanti came out and said, undefined, sir? Correct. No, that we're in unit 2. I'm giving you another term, discontinuous. I couldn't give you discontinuous before. Why? Because we're only now learning about continuity. See here, continuity rather, and differentiability. All right. So know that you know that we're doing this thing. So watch me again. Watch me again. The function is undefined when the denominator equal to 0 every single time. I just did a question with you to find the limit of a function as it tends to negative infinity. And when we evaluated the limit, we got 5/0. And we say that the limit of the function is undefined. Why did we say it's undefined? Because the denominator was equal to 0. Hear my story. I'm a storyteller. The story says the function is undefined when the denominator is equal to 0 every single time. Is there anybody in the class that don't catch that yet? Okay. When is the function undefined again, class?
So when the denominator is
equal to 0.
Amen. All right. No. So it says to find the values of x for which this function is discontinuous or undefined. So therefore, Locarno, wake up. Locarno. But this one not easy.
Sir, I'm there, sir. I'm there, man. I just don't like they give me a little time to.
Oh, okay, okay. All right. So you ask a question, son, and I'm here now to give you a second opportunity to fully understand the factorization. So it says the function is undefined when the denominator is equal to 0 every time. Watch me. Therefore, I'm going to set the denominator equals 0. Therefore, x squared plus x plus 9x plus 20 equals 0. X squared plus 9x plus 20 equals 0. So we're going to factorize in order to obtain the value or the values of the unknown. And we're going to do this stuff. Again, we're going to be multiplying the coefficient of x squared by the constant. The coefficient of x squared is 1. The constant is 20. I need two numbers. When multiplied together will give me 20, but when added will give me 9. And you can see that 5 times 4 is 20, but 5 plus 4 is equal to 9. So I'm substituting that 9. I'm substituting this 9 for my factors 5x and 4x. I'm grouping. I'm going to put the first 2 in parentheses, leave the middle sign out every single time. Once the sign is a negative between the parentheses, you have to flip the last sign. If the sign is positive, do I flip it?
No, sir.
I
No,
do not.
Sir,
I do not flip it. Good.
also need to follow the first bracket.
Right. And whatever sign is in the first bracket must also be the same sign in the second bracket. What is common here that is common there?
X, sir.
I'm going to take out my x, good. And what is going to be left is going to be x plus 5. And what is common between 4x and 20?
4.
4. And what is going to be left is going to be my x plus 5. And what I tried to do here was to color code it so that you can see what is happening. What is common here, that is common here, is going to be my x plus 5. So I'm taking it out. And what is going to be left will be my blue, my x plus 4, and all of that. And it's going to be equal to 0. It's going to be equal to 0. Why, sir? Because the question says the function is undefined when the denominator is equal to 0. So I have to set it equal to 0 and solve for the value or values of the unknown. So therefore, either x plus 4 is equal to 0 or x plus 5 equals 0. And if x plus 4 is equal to 0, that means x is equal to negative 4. And if x plus 5 equals 0, and you're trying to find the value of x, it means that it's going to be equal to negative 5. So I can say to you that this function has 2 points of discontinuity. What are they? When x is equal to 4, or when x is equal to negative 5. Let's go back. When x is equal to negative 4, or when x is equal to negative 5. Proof? When I substitute negative 4 into the function, I'm going to get negative 4 squared is 16. See? I raise a negative number to an even power. The answer is positive. And 4 times negative 4, 9 times negative 4 is negative 36 plus 20. 16 minus 36 is negative 20. Negative 20 plus 20 is equal to 0. So I'm going to get 1 over 0. Similar to the question that we just did a while ago. And we got 5 over 0. Once a 0 is in the denominator, the function is undefined. The function is discontinuous. All right? And similarly with the 5, with the negative 5, I'm going to get 1 and 0. All right. Are there any questions? Are there any questions? Are you understanding?
Yes, sir, I understand. Where's the
All
far,
right.
sir?
Say it again?
Yeah, sir, I'm saying so far, I'm getting it, but can do about 2 or 3 more examples.
You don't have to worry about that, Papa.
Sir, can you scroll up a little bit? The definition for the solution. Thank you.
No problem. All right. So you don't have to worry about that, Papa. Because here is example 2 for you. Look at the bottom of the page, guys, and you'll see example 2. I'm going to give you, Lecarno, I don't want you to see Paulina, Papa. I'm going to give you a couple of minutes just to do that. I'm going to start off with about 5 minutes. And here the plan. It's no 19 past, blowout. Time is running. It's no 19 past. I'm going to give you, I may do this exercise up to about 7:30 so that I can briefly introduce something else. I'm giving you a 5 to do that question. Example 2. Start from it, please.
Sir, you can zoom out. Can get a screenshot there, sir. All right, scroll back up. I think when I scroll up, I can't see everything.
That's it. I can move.
Yes, sir. Come on, sir.
All right, do that.
Sir, I'm done.
I heard you when you said that you're finished, but I was waiting for the others to come say something too, but nobody else said nothing.
Finished
Yes,
as
sir,
well,
I'm
sir.
finished.
Yes, sir, finish.
Yes, sir, finish, man.
Okay,
Finish,
what's
Which
the
man.
one?
answer?
I proved me that, sir, but
Sir,
Negative.
negative equal to negative
-7 and -8.
-7, -8?
Yes, sir.
yes,
But that
sir.
not, but that not right.
Yes, sir.
Sir, how come?
Sir,
Not right.
either x plus 7 equals 0 or x plus 8 equals 0, which when you're solving for x, it will give you a -7 and -8.
All right, very good, guys. I'm proud of you.
Sir,
Yeah.
question. It
Yes, Papa.
matters if I have it on the opposite sides. Can I have x equal -8 or x equal -7?
What is 1 plus 2?
Okay, sir. 2.
Okay. All right. You
Yeah,
said 2 a while
I'm
ago?
getting it. Wait, no, we say 1 plus 2.
And you said 2?
I think you say 1 plus 1. Sorry about it.
All right,
So
cool.
I'm gonna go wrong, sir.
What you get?
So I'm gonna get x plus 7 equals 0, x plus 8 equals 0.
Yeah,
So I
same.
get a negative there.
Because you have to solve it. Them said you have to find the values of it. So you have to know, set it equals to 0 as you did. See what do I add to 7 to get for it to become 0? It has to be the opposite, which is
Yeah.
-7. And what do I add to 8 to get 0? It has to be the opposite, so it's gonna be -8. Hello?
Yeah. So
Oh, okay.
Sir, can I repeat?
Say it again, Alwin.
Repeat what I said a while ago. Please.
No, what Nigeria was asking him, say him finish him answer right here, so I want to know where him go wrong. So I'm saying to him that you're not wrong, it's just incomplete.
Oh.
Because I need to find a value or values. Value or values. So when him have the x plus 7 equals 0, I'm asking him what value of x will make x plus 7 equals 0. And then him said -7. I said, yeah, that's how we do it.
All right. My question is, sir, after we reach this, we have to substitute into the function, or it complete yourself.
It's complete in a blue.
Oh, good.
You know, I have to give me the value or values of x.
Yeah, how much above you show it proofs. I mean, I wonder if that was a
Oh,
part.
no. The proof, no man. Hold up. You remember the first week of school? Take my time and go
Yes, sir.
You see this? You see the first example I did right here? I was just showing you the proof. You see, going forward thereafter, you don't need to do no proof.
Okay, sir.
But I mean, for you to, you see, when I say you don't have to do no proof, go ahead.
You know, saying I was wondering if I did something wrong, you know, so I'm glad for that question by Alvin, because
Yeah.
I
That's
did
what
the
I'm saying.
proof
So you
part.
don't, yeah, in a proof part, you get what? You don't get the answer?
Yes, sir, what I did it, as in I work it out. I was wondering if I had to do that.
Right. So I'm saying to you, the proof part is just to convince you at the onset that you are right. The proof is just for you to make sure, say, where you have this right on paper. Because if you do the proof, you're not going to get any extra marks. If you don't do the proof, you're not going to be penalized. This is where you're going to get the mark. But the proof is to convince you to make sure that you have not made a mistake. You follow me?
Yes, sir. Yes, sir.
All right.
Yes, sir.
Another question, sir. You're a stickler for these things. We have to have the either, and then this implies that supposed to remember these words, so we don't remember them.
And guess what? The amount of questions you're going to get, Evan, you're going to remember them. So next question here now. So now that you ask me, you're going to write it either, and you're going to write it implies. Practice make perfect. So go on. Number 3, quick and fast. 4 minutes this time. 4 minutes this time. Whoa, 7:30 gone. 4 minutes this time.
Sir?
I'm here, man. Go ahead.
Oh, I'm just seeing the question.
Oh, okay, cool.
All right, sir, finish.
Alrighty, alrighty, alrighty. Always stay, always stay, always stay. Everybody finish?
Yes, sir.
Yes, sir.
What's the answer?
Negative 2 and negative.
Yeah, -2.
Negative 2 and negative 2 and negative 3?
Yes, sir.
2 and negative 3.
That one more.
Come again, Nestor.
All right. Because
Work it out, but can't get the
only get
positive
Sir,
side
ano that
out,
me
sir.
get?
In not
Me not done yet. Yeah, that
negative
me
2
get,
and
sir.
negative 3.
continuous.
X,
When
me
I
get X plus.
multiply
Yeah,
negative
that's
2
what
by
I get.
negative 3, I'm going to get positive 6. All right?
That's
I'm
what
going to
I
get
get,
positive.
sir.
Very good, Andrew. I'm going to get positive 6. I don't want positive 6. I want a negative 6. So on a look back home, me just put, listen to me. I'm going to shake
Yes,
up.
sir. No, sir. Fuck, sir. Cause I couldn't get that
Sir,
5x,
6x
sir.
minus X, them should I use?
Yeah. Big up yourself, Andrew.
Dude.
Sir, this is where I'm heading to. I'm gonna complete it, but this is my mindset right now.
All right. Big up yourself. The rest of them are going through again. I love the sound of this. Very nice. Juliana,
Yes, sir.
are you with us? Right?
Sir?
Are you with us?
Yes, sir, I am.
I'm not hearing you at all.
Sir.
Yeah, man. Thais, are you with us? Come in and shame. But I heard from Tajay. Mappy can't speak. Yeah, I'm not hearing from those of you. Chrisanne, I don't like when it's so silent, you know. I'm worried.
I'm not with you as yet.
Okay. All right. Take your time. I'm projecting
Almost
that.
there, sir.
All right. I'm projecting that. Take your time. Take your time. Take your time. Take it to What keep though? Seriously. What one? Want to see it now?
Yeah, yes, sir. I think we catch it now. I know, sir.
One more for the road.
Yes, sir.
Example 4. Two minutes for this one.
I'm not see.
You see it? You not seen example 4?
Seeing it now, sir.
Okay.
Finish, sir.
Finish, sir.
Good job. Good job. The rest of you? 1 minute left. 1 minute left. 1 minute left.
Sir.
Finish, sir.
Okay. All right. Good. Good. I need 2 more people, and then without the answer. I'm seeing 1 answer already in the
Finish,
chat.
sir.
All right. 1 more
Finish, sir.
person.
Finish,
Okay.
sir.
What's the answer? What's the answer?
It's +2 and +3.
1, 3.
That's better, that. So much better than class, sir.
leave my pretty student alone. Oh. +2, +3. That not so right though.
So that is right.
Very
Sir, you
nice.
can't do that, sir.
I love it. Very nice. Very nice. All right. So I glance at the
Sir, my problem.
Go
So
ahead.
guess what my problem, sir? We keep leaving it at either x minus 2 equals 0 or x minus 3 equals 0.
And you see, the next time you do that, Nigel, I'm gonna charge you $1,000 a piece. US. You thought it was Jamaican, right? No, man, they can't do that, man. You have to go all the way down.
All right, sir.
Sir, I'm gonna like chicken, sir.
Say it again.
I like them chicken, sir.
Yeah, man, you have to get the factorization out of the way. All right. So I look at the clock and I recognize we have.
Sir.
Go again.
I thought we were 3 and 2, sir.
Yeah, the answer is 3 and 2. You're not seeing it. Look at the bottom of the screen.
For the first one, sir.
The first one is 6 and -1.
Scroll up back, sir.
Teacher, -6 and +1 rather.
No, yeah, it's the same.
It's not the same thing. This one is x squared plus 5x minus 6. And this is x squared minus 5x plus 6.
So someone would get the answer for the second one for the first question.
Yeah,
Or
but it's the
previous question.
Let me guess what you have to say. And that's why I put that question there, because I want to show you now, and I'll say, go, you have to be careful. If you get your factorization out of the way, you're good to go. So I was saying, I'm seeing we have about 10 minutes left. There's no way I'm going to be rushing to introduce a new topic to you because I want to be able to do a good job at it. So what I'm going to be doing is to see if I can find
Can you just scroll back?
two past paper questions.
Let me get the correct, sir. Because a positive, like a +6 there, so the event them used before, would I right? When we get the 2 and the 3. Well, since the previous one was a -6, that's why the 3 and 2 would work.
Correct.
Okay, sir. I think we understand now.
All right. So again, now I have 10 minutes. It's not going to afford me a good opportunity to introduce the next topic. So I'm going to defer that topic until Tuesday. But hear me out. It's a Tuesday. I'm not going to give you that grace period of 15 minutes. So when 5 o'clock comes, I'm going to start because I need to make up for some lost time. So I can't give you a grace period. I'm hoping to start and finish that topic on Tuesday. So I'm going to ask those of you who, if you don't leave out yet, put in a headset, listen to what is happening. When you get your recordings, you can follow through. So I have found a past question that I am going to be projecting. Go ahead, Nigel.
So as it relates to this class recording, or these classes recording, are these posted online, sir? Because I know you had a challenge with the recordings the last time.
YouTube channel.
You heard what the students said a while ago, Nigel?
No.
Yep, they're uploaded, sir. All the videos are uploaded.
Okay. I keep seeing other semesters, sir, when I say our class, that's why.
No, man. Check again, please. They were uploaded.
Our class there.
No problem.
Say it again, Demo.
Our class recordings are there.
Yeah, man. Yeah. So Demo is confirming Mason that the recordings are there.
Yes, sir.
You can just go on. So as soon as I get this one tonight, early tomorrow morning, thereabout, I'll upload this one so you can have it. All right. I found a past paper question.
Please do, sir.
Say it again. All right. I found a past paper question, 2018. And I'm not going to give you any instructions. I'm going to say how many of you listen to when sir talk. You're going to take 4 minutes to do this question, and then I will wrap up the class following. Sure, Sir Matthew. Not a problem. Logan. Thank you, please. Logan, where are you? I drop a secret. Logan, drop a secret. Logan? Then let me ask you. Then suppose me drop a secret on it now. Now, I'm not gonna like it. Logan gone.
Finish, sir.
Nice. Soon come. The blue one gone. The blue one. All right. Word of caution as you wrap up this stuff. Word of caution, please. I know we're all tired. This is a Friday evening. I deliberately not go on a bed. I deliberately am sitting up. If you try and get too comfortable in a settee or in the bed, it is not going to work. Not for this class alone, for any class that you have. Once you're too comfortable, you're going to doze away. Don't lie down for any class. You're going to sleep off. Always sit up and try to be alert. Yes, please.
Sir, I think you lose me here.
Where?
The question. Yeah, understand it, sir.
Okay. All right, no problem. All right, so let us get into it because I hear some people say to finish. Julie, and tell me where I lost you. What is the method that we normally use? What we normally do?
Sir, usually we factorize, sir.
Factorize what?
The coefficient of x.
No, ma'am.
No.
Tell me the method. What we do? What's the method for this?
Sir.
Yep.
Is it that we divide all of the numbers by the x?
Hmm? Follow the methodology. Follow the methodology. Can anybody suggest what to do right here, guys? Please.
Factorize the denominator.
What are you going to do before you factorize the denominator? You are going to
equate it to 1
Analyze
over 0.
equate the denominator to
1, sir.
Zero.
To what?
Oh, wait, the
To
denominator?
To
To
zero.
zero. Denominator
Yes,
0.
you're equating the denominator to 0. And then, Ashanti, what do we do?
Factorize the denominator.
Factorize the denominator. So, Juliana, you're going to put the denominator to equal to 0. So you're going to let x cubed minus 4x equals 0. And
Okay,
then
sir.
you are going to factorize the denominator. I give you a minute to start something, but I have 5 minutes in, and I'm leaving you at 8 o'clock. So you have
Okay,
not
sir.
5 minutes. You have 5 minutes for class to finish. I'm giving you 1 minute. The rest of you who didn't get it, you have 1 minute, and then we're going to wrap up in 4 minutes time.
You know, I'm not seeing this one. Not seeing this one.
You're not seeing this one at all?
Not quite sure what to do in order.
Okay. I'm going to charge you. You owe me $1,000 US. So the first thing we're going to do, we're going to let the denominator x cubed minus 4 equals 0. What is common between x to the third power and negative 4x?
X.
So we're going to factor out the x, right?
Yes, sir.
What is going to be left?
X bracket x squared minus 4 close bracket
Equals 0.
equals, oh yeah, equals 0.
Very good. And then what
And
do we
then,
do?
and then after that, you can have x. You can factorize it out again or something. I'm not sure me just, but
Yeah, man, you factorize
x,
it out and get what?
x bracket x plus 2 close bracket open bracket again x minus 2 close bracket equals 0.
And
So there's some stuff in that. So if we do it after this now.
all right, so that's
Oh,
what you
never
have.
mind, sir.
And then what next?
No clue, sir.
Sir, you function.
Tell me what to do. Tell me what to write.
So fx equal 9x minus 10 divided by open bracket x.
Say what?
Open bracket.
No, man.
Sir,
No.
Sir, the answer could have been that it is a positive 2 or negative 2.
Yeah, and
And then you can put the either uh what can I try to say? You can work the equation for the tops and 9
positive, negative 2. What other value you're missing, the more?
equals 0.
and 0. All right, so this is what is happening. So the more I need to answer a question though. I'm so happy that you got this x plus 2 times x minus 2. What is this known as, the more? This factorization known as from here to here. What is this? Has a special name.
So the grouping?
Difference of 2 squares, sir.
Very good, Reggie. The difference of 2 squares. That's the difference of 2 squares. Excellent, Raj. That's the difference of 2 squares. The difference of 2 squares. So the more you got the x2, -2 and +2, but remember there's an x outside here, so you know, watch me. So either this x is equal to 0, you know. So either x equals 0.
Yes, sir. The part that me get confused on because you see
Yeah.
the x is like Jano. What am I gonna do with that part there?
Right. So it's a 4-mark question. So imagine when I want examines to this question for 4 marks. You know, must do it and get it and say thank you, Jesus. Must get it, you know. Easy 4-marker. Easy 4-marker.
Is it 4 marks? No, but before, man, tell you, 4 marks look hard.
Sir, question. So what was the top, the numerator for? Was it just a distraction then?
Yes, sir. Because
So
remember what I said to you, Evan? It is only undefined when what happens.
Denominator
equals 0.
Denominator equals 0. I don't care about the numerator. The numerator can be anything. I don't care. I only care about the denominator. Can't equal 0. That is it. And that is the end of the class. Big up on yourself. I will send something to Lecarno and he will share with you guys. But for now, have yourselves a wonderful rest of the night.
Sir.
Yo.
Thank you, sir.
You too,
Broken
sir.
promises, that sir.
With what?
You told me the same thing last time. I'm gonna get it down.
Hold on there. Lecarno, I never sent you something last time. Lecarno
I want
gone.
the truth in our group, man.
Yes, sir. And I sent it to the group, so no one can. They never get it.
10 of the group, sir, for real.
Kenneth, take it back.
I'll take it back, sir.
Okay. I forgive you because I know me and Lecarno do that thing and Lecarno send out something for you. Sure. All right. So Lecarno, give me a few here.
Yes, sir.
All right, easy. Big up on yourself. Later.